Welcome back to the QST YouTube channel. Today I'm gonna be solving the 11S non-transition mechanics quiz. Let's go. The velocity time graph of two moving objects denoted I and double I are presented below. Which of the following statements is necessarily true? First, we know it's a VT graph. So we won't know anything about the position if it's behind or ahead. So let's eliminate this. That's what we're gonna eliminate. Now for the acceleration, which is the slope, the steeper is the higher the acceleration, since it's a VT graph. So as we can see, I is like steeper than double I. So object 1 has higher acceleration than object 2. Number 2, wait. Okay. In a 3-kilometer run, Sam covered the first 1.5 kilometers at a speed of 0.6 kilometers per hour and the second at 0.8 kilometers per hour. So for this one, we know that velocity is equal to distance over time or speed, whatever, doesn't matter. So time, we need the time so we can calculate for the entire run, which is 3 kilometers. So time is equal to distance over velocity. So time is equal to, so time for the 3-kilometer run. So this first distance is 1.5 over the speed, which is 0.6, plus 1.5 over 0.8. This is to find the time. This will give us, wait, 1.5 over 0.6 plus 1.5 over 0.8. That will be equal to 4.375. And then again, velocity is distance over time. Now we have time for the entire run, so it will be 3 over 4.375. So 3 divided by the answer, which is 0.68, which is 0.7 to 1 decimal place. Number 3. A motorbike rider moves along a straight road due north for what should be a 300-kilometer trip. She covers 110 kilometers in 50 minutes and then backtracks 50 kilometers in 20 minutes to see a friend. After seeing her friend, she continues her journey to finish it in 170 minutes. First, let's start the graph. So here in this direction, which is north. So she covers 110 kilometers. So here to here, first of all. No, that's too short. You can make it any length, but like just so for the sake of the video. So here at this point, 50 minutes and 110 kilometers. Then she backtracks, that means she went back 50 in 20 minutes. So here it's at 70 minutes, but it's at 60 because we do 110 minus 50 since she went back from 110 50. So this will be 60, and then after that she continues her journey Okay, wait. This will be 110. This is 50. Don't know if. And then from here, we will continue moving till the end of the journey. The end of the journey will be here, which will be at 170 plus 70, which is 240 minutes, sorry. And this will be at 300 kilometers, because they said originally that the whole trip is 300. So okay, now they want the distance. Wait, and this one, like this one arrow, I'll put it here, is 240, because again we went from 0 to 110. Okay, and then she went back 50, so we're at 60 now. And then from 60 plus what will give us 300, which is the end of the journey. That will be 240. So 240 will be this arrow, to this big arrow. And the distance will be like all of 110 plus 50 plus 240 added together, which is 400. 110 plus 50 plus 240. For the displacement, you just do the final minus initial, or basically the entire journey. But as we know, displacement has a direction. So they said due north and 300 kilometers trip. So it's gonna be 300 kilometers to the north. Now to find the velocity is equal to displacement over time. Time is 240 minutes, but it has to be in hours. So 240 over 60 is 4 hours. So it will be 300 from part B, which is the displacement, over 4 hours, which is 75 kilometers per hour to the north, because the journey is to the north. Number 4. A particle moves along a straight line from the origin is given by the equation 4t squared plus 3t minus 5. Okay, now to find the displacement, we're gonna do x of t1. X is a function, like 4t squared plus 3t minus 5 is a function, minus x of t2, or the other way around, like t1 and t0 to make it easier. And in this case, t1 is 3 because they want a t is 0 and t is 3. So first we're gonna have to substitute, or actually you can just put it on the calculator like this. But wait, I'm gonna need to remind you that t1 is 3 and t0 is 0, so we don't make mistakes. So we're gonna do 4 times 3 squared plus 3 times 3 minus 5. All of that minus 4 times 0 squared plus 3 times 0 minus 5, which will give us 45 meters. The average velocity of the particle between t is 0 and t is 3 is equal to. For this one, we're just gonna do again So this, goodness, as we know, velocity is equal to delta x over time, right? Okay, we have delta x right here, which is the displacement, and the time, it's not the time itself, it's the elapsed time, so which is 3 minus 0, which is 3. So we're gonna do the answer from part A, which is 45 over 3, which is equal to 15. For C and D, it is complicated, like, if I'm not mistaken, I don't, oh wait, no, let me do it in another way. So for this one, for part C and D, for part C, for the velocity of the particle, okay, we're gonna need to, like, okay, so velocity, the velocity in with the time function is equal to the derivative of x, which is like this. So we derive 4t squared plus 3t, which will give us v of t is equal to 8t plus 3. And then we substitute 2 here, which will give us 19. And now, to get the acceleration, right? For the acceleration, you could you could derive x twice, or you could derive v once, which we already have right here. So this is v. We're gonna need to derive v so we can get the equation of A. So A will be 8, that's it, with no t, which means that the acceleration, like, it does not matter about what time, whatever, the acceleration will always be 8. Number 5. The graph below shows the variation of the velocity of a dog during a given time interval. Okay, so for this one, we already know that the acceleration is delta v over delta t, or like time, which is the time elapsed. So delta v goes from 2, from 2 to 1. So it's gonna be 1 minus 2 over, during the first 5 seconds, sorry. So during the first 5 seconds is till here. So the velocity ends at, as we can see here, -1 minus 2 over 5, which is -3 over 5, which will give us, so -3 over 5, which is -0.6. Number 6 is glitchy on SDP, so I couldn't solve it. But anyways, number 7. Below is the position time graph of two toy trucks, A and B, moving in the same direction. Now the velocity is basically the slope. It's the slope in xt graph. Okay, so first of all, let's find the velocity of truck A. First of all, we need 2 points. we can take this point and this point. So we have 1, 3 and 0, 2. So 3 minus, wait, sorry. Yeah, no, I was 3 minus 2 over 1 minus 0, which is 1 meter per second. The velocity of truck B, we're gonna need to do the same thing again. Find 2 points and then get the slope. Now for truck B, again we'll take 1, 3 since it's the same as point A, and we're gonna take 0, 1. So again 1, 3 and 0, 1. So again we're gonna do this. 3 minus 1 over 1 minus 0, which will be 2 meters per second. The meeting time is easy. It will just be the x-axis of the intersection. This is the intersection. The x-axis, it will be at 1 second. And then the meeting position will be the y-axis since x is the position. So 3 meters. Number 8. The diagram below shows the change in position of a remote control car in the race as a function of time. The remote control is momentarily at rest when t is 0.5. So what they mean here is that it's not moving. So like it's momentarily, let me zoom in. It's momentarily at rest over here, which is at, wait, if I zoom out it's gonna ruin it, which is at 0.5 seconds. Wait, do they want in meters? Yeah, 0.5 seconds, okay. Between 0.5 seconds and 2 seconds, the velocity of the remote control car is negative. How do we know this? So from 0.5 to 2. We can tell that it's negative because the line is downward sloping. Like this, for example. The average velocity of the remote control car throughout the motion. Okay, so we're gonna take the final point and the initial point. So we're gonna take 2, 0 and 0, 0.5. And then again, velocity, we do the slope. So we do 0 minus 0.5 over 2 minus 0, which is equal to negative 0.25 meter per second, which we have here. Number 9. What characteristic of UARM causes the VT graph to be linear? Whatever. The acceleration is constant in... Look, this is something to be memorized, but when the VT graph is linear, like, VT, when it's like this means acceleration is constant. Number 10. Consider the velocity, the VT graph of an object in motion shown below. The accelerations in each phase shown below are denoted. Okay, in which phase is the acceleration the highest? Here they most probably mean the magnitude. You could do it in two ways. You could do it visually. You can notice that phase 1 isn't as steep, while phase 2 is really steep, while phase 3 there is no acceleration, there is just a constant velocity. Or you could calculate the slope for each one. You could do I'm not gonna do it like, you know, I think it would be way easier if you do it visually. I think it's clear here, but you could calculate the slope, which I'm not gonna go into as I explained it in the previous questions. 11. The time interval which the toy car is at rest. When the toy car is at rest, that means the position is not changing, or it's gonna wait. Gonna change the color. Okay, again. So rest in the xt graph is equal to horizontal. It's gonna be equal to horizontal. In the VT graph, we'll see later. So the time interval which the toy car is at rest. So we're gonna be looking for which part of the xt graph is horizontal. So it's this part from 0 to 3. The farthest point from the origin the toy car reaches. Okay, the farthest from the origin, that means like the farthest from this line. So what is the highest, like highest or lowest point? It would be this, right? And they want the position of it, so that would be 10 meters. The net displacement of the car. So for the displacement, we're just gonna do x final, which is 10, minus x initial, which is 6. So you do 10 minus 6 is 4 meters. That's for the displacement. Meanwhile, for the distance, that's a different story. So let's start from when the car changes position, since here the car is at rest. So we start at 6. Then we go all the way to 10. So first let's find the negative 4. We go all the way to negative 4. So we're gonna do, actually we could do the sum of the absolute value of all the displacements. So let's say x, which is the distance, could do the absolute value of delta x 0 plus absolute value of delta x1, so on and so forth. Okay, wait. Okay, so we're gonna do the absolute, let's take this as x0. I'm gonna make it x0, but it's delta x actually. So absolute value of the final, which is negative 4 minus 6, which is equal to 10. So that's x0. So x0 is 10 meters. And now we're gonna go from negative 4 all the way, wait, let me change colors. Negative 4 all the way to 0, the origin. So again, plus this, okay, I won't mark it, it's x1 basically, 0 minus negative 4, final minus initial, which will give us 4. So 10 plus 4, I'm gonna make it in blue, plus we have this line. I hope you guys can see it. I'll call it x2. So from 0 to 10. So again, absolute value 10 minus 0 is equal to 10. This will give us the distance, which is 24 meters. Okay. Now for part E. The toy car is at the origin. So it intersects the origin. We're gonna need to know this. It intersects, like, it meets the origin when, oh my goodness, why can't I, when we intersect the x-axis. So at what points do the line intersect the x-axis? We have here and here. So point 1, let's say P1, will be at 6 seconds. Then P2 will be before 15 by 2, which is 13 seconds. So the answers should be 6 and 13. Yeah. Number 12. In the first leg of motion, a bicycle accelerates from rest in the positive direction at 1.5 meters per second for 6 seconds. In the second leg of motion, the bicycle decelerates to a full stop in 5 seconds. Okay, first of all, we need, this is annoying. So first we're gonna need the velocity of this one. So acceleration is velocity over time. So we need the velocity. The velocity in this case, wait, gonna need to derive the rule. V is equal to 80 acceleration times time. Okay, so now let's find the velocity of the first leg. So 1.5 times 6 is equal to 9 meters per second, right? Okay, and then we're gonna need to find the acceleration again for the second leg, because look, once the first leg is done, we're gonna be at 9 meters per second, which is like the same velocity at the start of the second leg. So it's gonna be 9 over 5 is equal to 1.8 meters per second squared. It will give us 1.8 meters per second squared, which is what we have here. The bicycle speeds up in a positive direction, which means acceleration is positive. The bicycle slows down in a positive direction. This means acceleration is negative. All of these are meant to be memorized actually, but I'll just read them so you guys can understand. If the bicycle speeds up in a negative direction, this means velocity is negative, but the acceleration is positive. It's complicated. Just memorize it like this. If the bicycle speeds up in the positive direction, it's positive. So, and if it slows down in the positive direction, it's negative. and then we're gonna do the other way around. So if it speeds up in the negative direction, the acceleration is negative. If the bicycle slows down in the negative direction, it's positive. Number 13. The graph below shows how 3 runners completed a 100-meter race. Which runner won the race? To decide this, we're just gonna figure out like which graph reached the 100-meter first. So let's okay, so for Charlie, I'm gonna draw it in black. She took 17 seconds. Bob took, let me finish knowing this. Bob took 14 seconds. Charlie took 17. While Albert took 12 seconds, meaning he won the race. Which runner stopped for a rest? To know which runner stopped for a rest, we're gonna need to find a horizontal. Because again, as I said, if we find a horizontal line, that means the object stopped moving for some time, and then it depends on the graph if they continue or not. But as long as we find a horizontal line, we know that it's not moving, and we're just gonna connect it, and we figure out that Charlie is the one who stopped for a rest. Now number 14. The diagram below shows the trajectory of a skier. What is the net displacement of the skier from t equals 0 to t equals 3 minutes? For this one, we're just gonna do the final, which is here, minus the initial. Or you can just figure out how long it takes from A to D, because D is at 3 minutes. Immediately, it's just the path from the initial to the final. 3 minutes is D, so you're just gonna go 40, 100, so 40 plus 100 is 140. And it's to the right because we're moving to the right. And displacement has a direction because it's a vector. Number 15. The graph below represents the position time graph of a moving object. What is the average velocity in the interval? Okay. Let's take 2 points. At t is 1 and at t is 3. So let's take 3, 6 when t is 3 and 1, 1 when t is 1. So we're gonna do 6 minus 1 over 3 minus 1, which is 5 over 2, which is 2.5 meters per second. Number 16. The diagram below represents the VT graph of a particle. Now look, the VT graph, okay, the acceleration is equal to Vt plus V initial. Basically, like slope equation plus V initial. Okay, never mind, ignore what I just said. Anyway, the equation of the velocity. For this one, we're basically finding the, what's it called? The slope, the equation for this line. So, first of all, let's get something out of the way. Let's get the, B part. When we do y equals mx plus b, the y-intercept basically. Y equals mx plus b, the y-intercept, which is the part which intersects the y-axis, which is 2. Okay. And now to find the m part, which is the slope, we just need 2 points. 0, 2, and 412. So let me just write it like this: 412 and 0, 2. So again, 12 minus 2 over 4 minus 0, which is 10 over 4, which is 2.5. Number 17. In the velocity time graph below, the speed of a car at t is equal to 1 is 1 meter per second. A straight line tangent to the point 1 second 1 meter per second is drawn. The instantaneous acceleration of the car at t equals 1 second to 2 decimal places is. So to find instantaneous acceleration, instantaneous velocity, whatever it may be, as long as it's instantaneous, we just need to find the slope of the tangent. That's it. Here they already gave us the point, one of the points. So 1, 1. And now we need another point. Let's take 5, 10. 5, 10. So we're gonna do, again, the slope. 10 minus 1 over, over 5 minus 1, which is 9 over 4, which is equal to 2.25. Number 18. A toy car is constrained to move along straight track between points P and T. The displacement of the toy car and distance covered by it are equal along the path. Look, for displacement is equal to distance, delta x is displacement, d is distance. I'll just keep it like this. The path should be straight line. Just put straight as st. Straight line and same direction. Same direction. So which is in this case simply PQRT. It's a straight line, and it would and like the displacement and the distance would be in the same they would be in the same path basically. Okay. The car moves along the track PQRQ. Now they want the displacement of the car. The displacement would only be the first letter and the last letter. So PQ, how much is PQ? It's this much, which is 70 centimeters. The distance covered by the car. Now let's analyze what PQRQ is. PQRQ is PQ plus QR plus RQ. So 70 plus 110 plus another 110. Let me just change the color. Plus another 110. So it's gonna be 70 plus 110 plus another 110, which will give us 290. Number 19. Oh my gosh, this question is really long. Okay. Assume that the car can change its direction by moving. Okay, a toy car is constrained to move along the straight track PQRT due to the. It doesn't matter. Let's just skip to the question. The average speed of the toy car. First, we need the distance. Speed is distance over time. But they want it along this long path. So what is this? This is equal to PQ plus QR plus RT plus TR plus RQ, and then to find the speed, all of that over time. So let's start adding values. Let's start up. So the distance of PQ 10, and then the time it would take 5, plus up plus down. What's QR? QR is 20. In how many seconds? 10 seconds. How much is RT? It's 40. And how many seconds would it take? 18. Here, don't get confused, guys. It's like different order. And then again, what is TR? It's 40 plus, well, how much time? 12 plus, how much is RQ? 20. How much time does it take? 10. We plug this all into the calculator. Okay, so 10 plus 20 plus 40 plus 40 plus 20 over 5 plus 10 plus 18 plus 12 plus 10, which is 2.36. The magnitude of the average velocity. This one, it's not that hard. Again, the velocity is the displacement. Velocity is equal to displacement over time. The time we found it in the first question, it's 5 plus 10 plus 18 plus 12 plus 10. I mean, yeah. And then we need the displacement, which is basically just PQ. And PQ is 10. That's it. So it's 10 over 5 plus 10 plus 18. Basically what we found at the time from part A, which is 55. So we do 10 over 55, which will give us 0.18. Let's scroll down. In which segment is the instantaneous speed the greatest? Now here we're gonna add another part to the table. Speed. We're gonna do the length over the time. 1, 2, 3, 4. So 10 over 5, 2, 20 over 10, 2, 40 over 18. We're gonna need the calculator. 40 over 18, 2.2, 40 over 12, 3.3, and 20 over 10 is 2. So it is TR with the highest speed. Instantaneous speed, same. Number 20. The motion of the glider is uniform in the interval 0 to 3. How do we know if it's uniform? Okay, as we can see, we know if it's uniform if it's increasing by the same amount. So from 2 to 5, 3, from 5 to 8, 3, from 8 to 11, 3, but from 11 to 15, it's 4. So we ignore this, so it's just from 0 to 3. The speed of the glider in the interval, so this interval, simply all we're gonna do is distance over time. That's it. 11 minus 2 or displacement, whatever. 11 minus 2 over 3, which is just 3 meter per second. Number 21. The location of an object on an x-axis at any instant with respect to the origin is known as the object's position. Average velocity is displacement over time. Average speed is distance over time. A model is a simplified assumption, and the position is a location with respect to origin. These are all definitions and rules that are meant to be memorized. Okay, the xt graph shown below represents the motion of a toy car along a horizontal axis. The time interval which the toy car is at rest. I think we solved this, no? I swear we solved this. Wait. So for part B they want the distance. It might seem hard, but it's not really hard. So let's start. x1 is from 0 to 20. x1, again, the displacement is the sum of all, the distance is the sum of all the absolute values of the displacement. x1 is equal to absolute value of 20 minus 0, which is equal to 20, plus x2. We start from 20 and we go all the way down to negative 8. So again, absolute value of negative 8 minus 20. This will give us positive 28 plus, and then from negative 8 all the way up to 4. So x3 is equal to absolute value of 4 minus negative 8. All of that in absolute value will be equal to 12. If you add all of these together, this should give us 60. Let me just make sure. And there it is. Now they want the average velocity of the particle in the time interval from 0 to 14. Now 14 is right over here. Okay, so velocity is the displacement over time, which is negative 8 minus 0, position final minus position initial, over 14. So negative 8 over 14. Let me just put it on the calculator. Negative 8 divided by 14 is negative 0.57. Number 25. The moment of time which the particle is instantaneously at rest. Now this is a relatively new concept. I genuinely took it today, like the day I'm uploading the video. We learned that, like, when it's concave down, like when the curve is concave down, the point where it's at rest is at the top or at the peak. This means it's at rest. So it is when t is 5. At t equals to 11, the approximate instantaneous velocity. Okay, so at t is 11, which is right here. This is basically a straight line, so we can easily use it for a slope equation. Let's just take this point down here, which is negative 12. So negative 12 minus 0 over 13 minus 12 minus 11, which is negative 6. Now here's something new. So instantaneous velocity, actually instantaneous speed, we're gonna make a relation, is equal to absolute value of instantaneous velocity. So now we got, as we said, instantaneous velocity as negative 6, right? So instantaneous velocity, which is negative 6, we put it all in the absolute value, we get that this is equal to just 6 meter per second, which is correct. Number 26. Consider 3 cars A, B, and C, all accelerating steadily at first and then continue their own motion at a constant speed. The speed time graph below summarizes the motion of cars A and B only. Okay. Now, to find the maximum speed of car A, we'll just find the highest speed of car A, which is 30. And now to find the distance of car B while accelerating, which is this part, there is an easy way to do it. We can simply use the area under the graph, which is a triangle in this case. So area of a triangle is equal to base times height over 2. Okay, the base is 0 to 15, which is 15, times height, which is from 0 to 20, which is 20, over 2, which is 150 meters. Okay, assume that car C has a greater car acceleration than A, but it has a lower constant speed than B. So basically what they're saying, they want the acceleration of C to be higher than A, but they want the constant speed of it to be lower than 20. So how are we gonna know if it's a greater acceleration than A? We want the acceleration of C to be steeper. So this isn't steeper, and this is, the constant speed is more than 15. More than 20. And this as well, it's more than 20. So this is the case because when it's accelerating, it is less steep than A, but the constant speed part is lower than B, which is 20. Now number 27, which is the last and final question of the day. The particle is instantaneously at rest at. So when the particle is instantaneously at rest, it is when it touches the origin, which are at these 2 points, which are at 8 seconds and 13 seconds. The instantaneous acceleration of the particle at t equals 5 to 1 decimal place. Now for this question, we're gonna need to find the area of the graph. The slope of the tangent to find the instantaneous acceleration. They gave us the points right here, which is a really good thing. So 1, 7 and 12, 0. Okay, that's nice. And then we're just gonna do the slope equation. y2 minus y1 over x2 minus x1. 7 over negative 11. Let me just plug it into the calculator. 7 divided by negative, put it on the fraction, 7 over negative 11, negative 0.63, which is correct because they wanted to 1 decimal place. Anyways guys, thank you so much for watching this video. We wish you guys the best of luck in all of your exams, and goodbye.